we're going to graph this quadratic equation. I'm going to show you a different way rather than using the function table. We're going to go ahead and graph it using a different method. First we're going to use the axis of symmetry formula. You need to know this. Go ahead and make sure you write this down and memorize it. You'll get to know it well because we're going to use it a lot. But it's a equals negative b over or divided by 2a. And the b's, or the b and the a, come from our quadratic formula up here. We have the a and the b. The a is the coefficient from x squared and the b is the coefficient with x. So this particular quadratic equation, y equals x squared minus 6x plus 4. We're going to graph that, see what that looks like. Now, this is quadratic since it has the highest monomial, the highest degree monomial is x squared. That means it's going to be quadratic, which means it's going to give us a shape of a parabola when we graph it. So let's go ahead and do that. Let's use our formula first. We have x equals negative b. Well, in this case, b is our coefficient of x. Our b is negative 6. We divide that by 2 times a. Our coefficient of x squared is 1. Okay? So we have the opposite of negative 6, which is 6, and 2 times 1, which is 2, and that gives us 3. So x equals 3. So our axis of symmetry on the x-axis is going to be 3. 1, 2, 3. We know we're going to have a parabola that opens either upward or downward. It's either going to open up or down and split right down the middle right here at 3. Now, to find out where the vertex is, where that minimum or maximum point is, we need to use this 3 and substitute it back in to our equation. So we're going to put a 3 in for x. So we have y equals x squared, or 3 squared, minus 6 times 3 plus 4. Now, when we work this out, we get y equals 9 minus 18, which is negative 9, plus 4, which equals negative 5. So our vertex is going to be 3, negative 5. Okay, so if we come over 3 and go down negative 5, 2, 3, 4, 5, vertex should be about right there. Now, the next thing we can do to graph this is to find where it crosses the x-axis. So we're going to plug in a 0. We're going to plug in a 0 for x. Remember, this is called the x-intercept. So we're going to have a 0 for x. So I'll just do that down here. Y equals 0 squared minus 6 times 0 plus 4. When we work that out, we get y equals 4. So when x equals 0, y equals 4. So that would be 1, 2, 3, 4. It'd be right here. So this parabola is curving upward, so which means it has a minimum point. And what you can do to graph this now is you can just look for the mirror point, the point that mirrors itself or reflects itself over the axis of symmetry. So this is 1, 2, 3. So if we go over 1, 2, 3 from there and up 4, should be able to put a point there and draw our parabola. So all we have to do is put x equaling 0, which gives us our y-intercept. I think I said x-intercept earlier. It's the y-intercept. and that gives us our point where it crosses the y-axis, and then we can mirror a point over the axis of symmetry. So once again, this is our vertex. Also, once again, a minimum point. And our axis of symmetry is this line here. Now, if you notice, the two examples, the one from last section and this one, both have had a positive value for A. That positive value for A makes the parabola open upward. When we have a negative value for A, the parabola is going to open downward. And that's the example we're going to do next. This is the second example, and this time we have a negative A value. So like I told you on the last example, this one should create a parabola that opens downward. We're going to graph it the exact same way that we just graphed example 1. Starting out with the axis of symmetry formula. Start out with x equals negative b, in this case b is 8, divided by 2 times a, and a is negative 2. So now we have negative 8 divided by negative 4, which gives us 2. So the axis of symmetry is going to be at 2. Now we can find that vertex by substituting in the 2 for x. So we have y equals negative 2 times 2 squared plus 8 times 2 plus 9. Now, the first thing we need to do is square the 2, which is 4, times negative 2, which is negative 8. Negative 8 plus 16 plus 9, that gives us 17. So the vertex is at 2, 17. So if we come over to 2 and we go all the way up, this is going to be kind of high. Let me just cap it out up here somewhere. Say this is 17. My vertex is all the way at 217. The next step is we're going to substitute a 0n for x to find that y-intercept. Where does it cross the y-axis? So if I plug a 0n, let's find out what y will equal. So we have y equals negative 2 times 0 squared plus 8 times 0 plus 9. And as you can tell, when you do this part and you plug the 0 in, the 0 is going to cancel out these two, and you're really just left with this number. So this is generally your y-intercept. So 9 is our y-intercept, 0, 9. So if we go 0 and we go up 9, let's just say that's there. Now we can tell this is going from, the vertex is coming down, so this means that this time we're going to have a shape that looks like this, meaning it's never going to go above 217. This is our vertex. Call this the vertex. And we're going to mirror this point. It's at 0, 9. We're going to mirror it over the axis of symmetry, over 1, 2, and up there. And then we can draw the rest of our parabola. Now, this is different. This opens down. That means our y values never go above 17. This is 2, 17. This is not called a minimum point, obviously. It's now a maximum point, meaning the maximum we can go up is 17. So this is called a maximum point now. So to reiterate this, our vertex will either be a minimum or maximum point every time. The vertex is that point at which it makes its change going from one direction and then changing over going the other way.